Okay, so now that we can categorize them, let's talk about the actual process of solving equations. So again, the first thing I probably want to do is look at the type. So when I look at this guy, I see the variable risen to the first power up in the numerator, where essentially I see y equals mx plus b, y equals mx plus b. So this is linear. And the way you want to solve a linear equation is the first thing you want to do is simplify as much as you possibly can, right, both sides. And then after you do that, you start using your golden rule to basically to get x by itself. So these are probably the, oops, I misspelled that. Alright, this is probably the easiest thing we can do. So this is a linear equation. This side I cannot simplify it anymore because there's no like terms. And this side I can't simplify because there's no like terms. So it's already simplified. So my next move is to start using the golden rule. You get to decide which side you want the x's to be collected. So how about I add x to both sides? I'm going to do it vertically. And as I add x, I could be adding 6. So there's my balancing act. And yes, I would like to see that from you guys as part of your work shown. It's a skill we need to learn to help us do some more advanced mathematics later so we know what we're doing. So I'm adding x to both sides and adding 6 to both sides. So the result is a new equation. As a matter of fact, we call it an equivalent equation. 2x and x gives us 3x. There's my equal sign. The 6's cancel out. 3 plus 6 gives us 9. And in this case, the x's will cancel out. So after adding x and adding 6 to both sides, we have the equivalent equation, 3x equals 9. Alright, so to get x by itself now, I would divide both sides by 3. So there's what that balancing act, that golden rule would look at. 3's will cancel out. 9 divided by 3 gives us x equals 3. And there's basically our solution. So we found the value that when I substitute it in, so here's kind of your check, makes things true. So 6 minus 6, we see that both sides equals 0. So we truly found the value that when I substitute it in, gives us a true statement. So I'm very confident that that is our correct answer. All right. In the next one, again, what type we're looking at? Well, if you take a look on this side, that's clearly y equals mx plus b. And if we had to simplify this, which we will do, because that's one of the first things we're going to do, this is also y equals mx plus b. Or notice that all the variables are to the first power and up in the numerator. So we definitely have a linear equation again. So to solve a linear equation, the first thing I'm going to do is simplify both sides as much as possible. So 9x plus 2 is as simple as we can make it. Alright, here we got to distribute. So we get 12x, I think, plus 8 minus 3x minus 6. This side is still simple. This side we need 9x and we get plus 2. Okay, and so we already kind of see something a little odd. Alright, notice that this side is exactly the same as this side. Alright, and so this means that we have is famously known as an identity. One side is identical to the other. And it means that x is equal to all real numbers. So any value of x you can dream. A nice integer, a nasty fraction, a really nasty irrational number, anything in our real number system is going to make this true. Alright, and so that's what it means for that. So be careful, be looking out at those things. This equation over here, oops, we call a, oops, almost gave it the wrong name. We call this one over here conditional because its truthness depends on a specific condition. X has to be 3 for that equation to be true. Over here, this is an identity because anybody's going to work, and we saw that within our work. So I could basically stop there. One side's identical to the other. Alrighty, so golden rule. Letter C, same idea. If we take a look at this, I can see that the variables to the first power and up in the numerator. So this is a linear equation. Alright, so the first thing I need to do is simplify both sides as much as possible. So I'll begin by doing a distribution. Be careful with your signs, right? We're subtracting a 3, so we get a negative 3 times 2 is a negative 6. A negative 3 and a minus x will give us a positive 3x. On the other side, right, minus 12 and plus 15x. So I think I distributed everything correct. Combining like terms, we end up with 15x minus 6 and over here we end up with 15x minus 12. All right, and if I proceed, right, if I continue on to start my balancing act, how about I subtract 15x from both sides and add 6 to both sides? We'll notice that over on this side, everything cancels out, so we're left with 0. And on this side, we're left with negative 6. Right, so that is, again, another kind of odd situation. And in this case, what we have, right, since this is never true, right, we're basically saying that there is no solution. All right, because we ended up, after doing all our good math, after following our little golden rule, we ended up with a situation is that can never be true. 0 is not equal to 6, right? We know that to be true. So that means that there's no value, right? You cannot find a value of x that when you plug it in, that will make this side equal to the other. Because this side, you can kind of see it right here. This is always 15 times the number take away 6, and this is always 15 times the number minus 12. So there's no way, like this one over here, they are identical, same terms. Here we do have a same term, but what's left is never equal to each other. So no value of x is ever going to work. This type of equation is called a contradiction. And in the world of mathematics, when you solve an equation, follow your golden rule, right, you're going to end up with 3 things to happen. You'll end up conditional. Our truthness depends on a certain situation. You end up with an identity, meaning everybody's going to work, all values. Or you end up with a contradiction, which means no solution. Those are the only 3 things that can ever happen when you're solving an equation, no matter what type of equation it is. So it also will have some significant impacts on graphs and systems and all that other good stuff. All right, let's do one more and then we'll cut this short because we're getting already, almost 7 minutes into this. Now, letter D, right, first of all, it is a linear equation. And because we've got the mx plus b, or x is up in the numerator of the first power. But we also label this as technically rational since it has a fraction. And so to work on this, there's a lot of things we can do. If you're very proficient with your fractions, you can, play your golden rule and, subtract 3/4 x and add 2/3, whatever you want to do. But in the process of simplifying it, what I like to do is clear the fractions. Because if I can clear the fractions, it makes my life a lot easier. And looking ahead, like these ones down below, I definitely would like to clear fractions if it makes my life easier. So to do that, what we need is the LCD. So looking at my numbers here, the common number that has 2, 3, 4, and 6 as factors is 12. So what I'm going to do with that is I'm going to take this side and multiply it by 12. And I'm going to take this side and multiply it by 12. So notice I'm using the golden rule of mathematics, right? I'm taking my equation and I'm multiplying both sides by 12. Now that looks a little messy, but look at the payoff. What I need to do now is distribute that. So 12 times a half, or 12 over 2, leaves us with 6. So we have 6x minus 12 times 2 is 24, and we're dividing by 3, which leaves us with 8. On the other side, 3 times 12 is 36. We're divided by 4, which leaves us with 9x. 5 times 12 is 60, divided by 6, leaves us with plus 10. And so by multiplying both sides by my LCD, what I was able to do is clear my fractions. And now I have something that's much more nicer to look at. And so technically what I did is I simplified by playing my golden rule. All right, in this case, finding the LCD and multiplying both sides. So carrying on, how about we subtract 9x from both sides, and I'll also add 8 to both sides. And so the 8's cancel out, leaving us with negative 3x on the left side, and we're left with 18 on that side. One last golden rule, we get that x equals negative 6. So there's the value that if I was to plug it in, would make this a true statement. So this is a conditional type of equation. Right, because its truthness depends on that condition. Right, so we're almost 10 minutes into that. I'll let you guys do the check. All right, but there's your first round of how we solve a linear equation, and we just kind of got a sneak peek, right, at how we're going to be solving rational equations. We're going to clear those nasty fractions. And last but not least, we've also found that equations have 3 names. Some are conditional, their truthness depends on a certain situation. Some are identities, they're identical, so everybody works. and then some are never true, they're contradictions, they have no solution. Right? So hopefully that's a good review, or maybe a good analysis. I'll see you guys in the next video for the next 4.